All right, so I'm going to spend the next 25 some odd minutes going over Project Skyline. So, first of all, Project Skyline is it's an internal project. That's why I call it a project. It's not an actual product. We're not making any announcements about it being a product. This is just a technology preview of some stuff that we're working on internally at Autodesk for animation authoring. So what we're using to kind of test this out is something called Hyperspace Madness, which is a game that we've developed internally with a hero character here, Sven, and a few enemies that I can go in and I can shoot. But we're using this as a test bed for a variety of our middleware tools. So, for instance, we're using it Beast for lighting. We're using Kinapse for the AI for our minion characters, our enemies. And we're using Skyline here to basically not only create the animation, but also to create the behavior. So in other words, to create the behavior, for instance, when he's running versus when he's jumping versus when he's crouching, and then what does he do when he starts to walk and he crouches, and what does he do when he's crouching and he fires. All that has to be authored, basically. So in the past, this would be basically done kind of in conjunction with programmers and artists. Artists would create the animation, programmers would integrate it into the game, and then there was this big wall between them where they had to throw assets over the wall, the artists did, to the programmers, and then wait until they could get it into the game, and sometimes that might take a day or two. Now, with Skyline, it's pretty much instantaneous. So let's go back in, and I'll talk a little bit about Skyline. So for starters, let's put my game over here on the side, because we're going to actually interact with that. Wow, they are loud over there. I don't know if I can actually outdo them. So what I'm going to do here is actually, well, first of all, I'll just talk a little bit about the relationship between Maya and Skyline. So this is what this is Maya, what you see on the left, obviously. How many people out there actually use Maya, just out of curiosity? A few people. David. All right, so this is Maya, obviously, and Skyline essentially is built on top of Maya. So Maya will be used for creating your animation, editing your animation, and Skyline will be used to get that animation into the game. So if I click this button here, that brings up a secondary piece of the UI. So it looks very Maya-centric. It actually has the Maya viewport in here, but this is actually the Skyline component. So this is what we call the game watch. And this is basically our interface between Maya and the game. It's our bridge. So right now I don't have anything in here, but what I can do is I can actually connect to a running game. So I'm actually going to connect to the game that's running here on the right-hand side. And what it's going to do is it's going to actually connect to the game. It's going to discover the assets in that game, the animation assets, and it's going to essentially agree upon what those are and then load the associated assets into Maya. So what I've got here is an actual representation of my character in Maya, in the Maya viewport. So one thing to point out is that this game could be running remotely. I happen to be running it locally, but this could be running on that PC over there, or it could be running on a PS3, it could be running on an Xbox. It doesn't really matter. You can connect to it remotely. And also, it's engine independent. We happen to be showing it with Unreal here. But it is engine independent, so you can integrate Skyline into your own custom engine, for instance. So I'm going to quickly go in here, and I'm going to set my viewport up so I can get a little bit better look at my character. And what you'll see here is I have a mesh and I have a skeleton, and that updates basically as my game updates. So for instance, as I go in and I trigger animations in my game for my character, it will update in the Maya viewport, and it will also update the camera. So you're seeing the joints. These are actually Maya objects. This is a Maya mesh and a Maya skeleton. I'm going to switch over into a simpler display mode where I'm just going to show the mesh itself, and I'll turn on shading here, and now you can actually really start to see what the character looks like. So as I jump in the game, it's going to trigger a jump in Maya. So what I want to do now is actually look at the character from a Maya point of view. So previously, I was driving the character with the gamepad, so I've got a gamepad here that I'm using to drive it. I can switch over into a Maya-centric mode, and what that allows me to do is actually, for instance, say, select the face and frame in on that face, and then use the Maya camera to actually start to look at my character and analyze the animation. So, for instance, if I'm comparing a walk cycle to a run cycle, I can come in here and I can focus in on the legs, and I can see exactly how those legs are blending and look for problem areas. So I can also decouple the camera so I can have separate camera controls. For now, I'm just going to switch it back to the game cam, and we're going to talk about this interface down here. So this is the time trace. The time trace is a graphical interface or graphical view of our game. So you'll notice that as I begin to trigger animations, if I go into, for instance, a jog into a run, or if I come over here and I trigger a jump, or if I trigger a crouch, and then I go in and I fire from that crouch position, all that is being basically displayed as these kind of graphical bars, and each one of these bars represents a different clip. So actually, if you look from the top down, At the highest level, we have our state machines. Our state machines are basically states with connections between them. So for instance, is he running, is he jogging, is he idling, and how do you get between those? And then as you dive in, we have things called markers. So we actually have the ability to mark where his feet hit the ground, for instance, and then we can send that data to the game so that the game can then do something with it. So it could be something like controlling how you blend from a walk to a run so that it blends at the footstep. Or it could be something like triggering an audio effect or triggering a particle system. So this data you apply can be used by the game in different ways. The cool thing about this is that you can also go back in time, and you can actually scrub the timeline and take a look at the history of your game. So I'm actually pausing the game, and I'm scrubbing through, and I'm actually looking at what I've done. So right about here, I jump. I can actually pause that, and then I can use my Maya camera to navigate around that and get a closer look at what that jump or what that fall is going to look like. So each one of these clips, each one of these bars that you see, these are actually the animation clips. They have an associated Maya file. I'm going to talk about that in a second. For now, we're actually going to go in, and I just want to finish out kind of the overview of the UI, and we'll talk about the node editor. So whereas the time trace at the bottom is essentially the history of your game, this is what has happened in the game, the node editor is the authoring aspect. This is where we create the behavior in the game. So I'm going to open up the node editor, and actually I'm going to frame in nice and big so you can actually see what's going on here. This is where all the magic happens. So this is basically the highest view of my behavior. So I'm actually looking at the state machine, or a series of state machines, I should say right now, that are actually blended together. So if I pull in, what you'll see is I have a body state machine, and the body state machine controls things like my running, things like my jogging, things like my crouching, and so on. And then I also have a weapon state machine, which overrides or composites on top of that, so that as I fire my gun, if I'm crouching, it'll work with a crouch, or if I'm walking, the gunfire will work with the walk. So that's just a blend on top of the body state machine. And then we also have something called a reaction state machine, which I can't really demo because this actually has to do with enemy fire. So as I'm running and I'm firing my weapon, I can also get hit by an enemy fire, and then I have some kind of reaction to that that gets composited on top of everything else. So if I dive in a little deeper here, each one of these state machines is a much more complex node structure. So if I dive into the body state machine, what I have here is a series of nodes that are essentially states with connections between them. So by default, if I'm not doing anything in my game, I'm going to be idling. If I trigger, if I use my gamepad or hit different buttons or use the joystick, I can actually go from an idle to a jog, and then I can go from a jog to a run, and then I can go from a run to a fall, which would take me to a land, which would then transition into an idle, and then I get back where I started. And you can see the connections and arrows that indicate the stream or the flow between these states. So I can even take it farther than this. So this is kind of the mid-level view of the state machine. If I dive into any one of these nodes, just double-click, it'll take me into the animation tree. So the animation tree is basically where all the clip animation resides, and it has some information in here about how to transition with those clips. For instance, I have different versions of my jog. I can jog forward, I can jog to the left, I can jog to the right. Those get composited together so that I can actually transition from a forward jog to a right jog. And then those get blended and ultimately fed downstream to the output of that particular state. We also have the concept of compounds. So I can actually go into one of these nodes, and then it's even a more complex node structure that has a bunch of essentially mathematical operations in here that essentially go in. It's basically visual programming. So if you've ever seen ICE and Softimage, it's a similar concept. It's visual programming with nodes. So let's dive out, or rather pull out, and talk about actually starting from scratch. So what I've got right now is a very complex node structure that took a lot of time to actually author. But if I wanted to start from scratch, we'll just kind of do a simple example. So the first thing that I would need to do if I want to create animation and put it into the game is to create a state machine. So the state machine is going to contain a series of states. First of all, I want to go in and name this something appropriate. So I'll just call this simple state machine. And then if I dive into that, I need at least one state within my state machine. So for instance, I need to idle or run or walk. Preferably, I would do more, but for now, I'm just going to go in and create a simple state, and we're going to call this my idle state. So I'll just go in and rename this, just so I know what it is. Now, every state has to have something in it, so it's not going to be empty. I'm going to have generally at least a clip, usually more clips within that state that get blended together in different ways. So what I want to do is create the simplest clip possible, which is an empty clip. So an empty clip is basically going to go in and essentially put the character into a T-pose. So it's essentially a pose, basically, which is predefined on the Maya side. I'll talk about that in a second. So now I've built a very simple state machine. So it's a simple clip with a single state within one state machine. Now what I'm going to do is I'm going to take that simple state machine, and I'm actually going to feed it to my game. So I'm going to basically take that and put it into the animation port for my game. So if you watch the game, now all of a sudden he updates, and that one state with the simple empty clip is now driving my character. I have no game controls at this point. I have camera controls, but I have no character controls because I haven't defined that. I haven't actually defined the behavior. So let's pull back. I'm actually going to get rid of all this extra stuff because it's just kind of cluttering up right now. We'll delete that, and then we'll dive in and we'll do something a little more interesting. So if I go into my simple state machine, dive into my idle state, I want to actually create an idle for this. So right now I have an empty T-pose. I want to create some animation for this. This is where Maya comes in. So now we go back to Maya, the kind of standard Maya interface, and then we create an animation. So what you'll see here in the upper right, this is my project interface. So this is actually a Skyline component. These are all the animations that are available to me right now. And they're all based on what's called a skeleton definition. The skeleton definition is actually kind of a template of my skeleton structure that then I can apply animation to. I build animation on top of that using any of Maya's tools. So I can use HIK, or I can use a custom rig, or I can bring in mocap data on the bones. So what I want to do actually is bring in something that's already been animated because I'm not going to take the time to animate it here. So I'm going to come into my locomotion clip group. The clip group is just a category of animation. So locomotion would contain idle, jog, and run, and so on. So I'll go in here and I'll create a new clip within that clip group. I'm going to call this my idle new. And I'm also going to load an existing file. So each clip is associated with a Maya file. So there's an associated Maya file. So I have to actually go in and import that or bring that in, identify it, whatever. So I'm going to go in and bring in something I've called idle alternate. So this is a different version of my idle. So I'm going to open that up. And what that's going to do is it's going to load the associated Maya file, which also contains the skeleton definition. And the skeleton definition is basically what Skyline cares about. So Skyline cares about three things, essentially. It cares about the joint structure, the skeleton. It cares about the animation. And it cares about some basic clip information. For instance, how long is the clip? Where does it start? Where does it end? And then a few other parameters that I'll talk about later. But right now what you'll see here is I've got a simple animation of my idle. So as I said, this could be animation on a rig, or it could be animation on the skeleton. This happens to be on a rig built on top of that skeleton. So if you want to see the actual skeletal structure, that's the skeleton underneath. Actually, it's not displaying. There it is. So ultimately what's going to happen is any animation that I put on this rig is going to be transferred, or rather baked, essentially, down to the joint level. So I've already created the animation. We're going to leave it here for now, and I'll come back to it in a second. But you'll notice in my project over here, it's created something called idle new. That's what I defined as my clip. So I'm going to go back into Skyline, and now I'm going to bring my idle new, the one I just created, into my node editor, and I'm going to connect that to the output of that state. Now watch what happens. As soon as I do this, the game will update instantly, pretty much, and now you'll see the idle that I just had in Maya. So let's make this a little more interesting, and let's actually create a couple of states that I can actually blend between. So right now, I have my idle, but that's all I have. I don't have any other control. So I'm going to go in and I'm going to create a new state, and we're going to call this my jump state. So I'll create my jump state, and again, a state has to have something in it, at least one basic clip. So I'm going to go in and import, or rather drag in, a clip that already exists. So this was pre-created in advance, but I've got a clip called idle jump weapon ready, which basically is a looping jump where he draws his weapon. Because I want the weapon draw in there so you can actually see the blend. So now I'm going to feed that to the output of the state. So now I have two states, idle state and I have jump state. Right now the idle state, you'll notice the green arrow, that indicates that I have, that's my initial state. So what I can do to test the jump, if you watch the game, if I right click and I reset this as my initial state, it's going to automatically update in the game, and it's going to show me the result of that state, which only has a simple idling, or rather looping jump in it. So what I really want to happen is I want the idle to transition into the jump. So what I'm going to do is reset the idle state as my initial state. Watch the game. It'll actually go back to idle. Now I'm going to drag a connection between idle and jump, and watch the game. As soon as I do that, it immediately goes to jump. So when you create a connection, all you've done is you said, I want to go from here to here, but you haven't said anything about how you're going to do that or when you're going to do that. So it's basically instantaneous initially. Initially, it's going to go right from the idle to the jump. If I actually connected the jump back to the idle, it's going to go back and forth between the jump and idle as fast as it possibly can, because I haven't told it when, I haven't told it to delay, or I haven't told it to blend, I haven't told it anything. So I'm going to actually get rid of that. I'm just kind of showing you that as a silly example. But let's actually go back to the original idle state. I'm going to pull back here a little bit, select the actual transition, And I have properties on that transition. Now, I can get a lot more complex than just this. I'll show you a more complex example in a second. But for now, what I want to do is I want to go in and define an event that will determine how and when I transition from the idle state. So a programmer or a technical artist would have created this for me. So somebody created an event for me, an AI event called doJump. So as soon as I hit that, or as soon as I enter that, what that means is that whenever I hit the A button, that's my doJump event, and that's going to trigger that transition. So now all of a sudden I hit the A button, and it immediately transitions to the jump state. But it hasn't done anything else. All it's done is it's basically flipped over to that new state. So what I want to do now is actually create a more elaborate transition. So I'm going to reset this, actually. We'll reset the idle state to be my initial state. And now I'm going to go in and do a really simple blend. We can do very complex blends. For instance, if you're going from a run to a jog or a jog to a walk, you can actually blend based on footsteps. What I'm going to do actually is just do a simple crossfade. So I set that simple crossfade, and I basically want to do it at the end of the transition, and then I want to define how long that transition happens. So I'm going to go in and put a value of 0.2 in here, which is a time, essentially. So in 0.2 seconds, I'm going to transition from, if you'll watch the idle, hit the button, transitions into the jump. So now I would go in and I would basically loop this back, connect the jump state to the idle, and I could create another event, maybe from the game, that would determine when I go back into the idle. So I'm not going to take the time to do that because I want to show a lot more. Let's actually go back and show something that's really interesting, though, and this is really the beauty of Skyline, is that all of this is still residing on top of Maya. I still have Maya to work with. So if I see something that I want to change, for instance, if you look at this idle, when I do my transition, watch the hips. The idle is really low. Now, I did this on purpose, obviously, but the idle's really low, so when it blends from that idle into the jump, it's doing it, it's very obvious, basically. He kind of raises up and then blends. So I want to correct that so that they're more in line. I basically want to change the center of gravity of my character for that idle state. So I'm going to reset that as my initial state. I'm going to go back to Maya, and I'm actually going to edit this original animation and have that automatically go into the game. So let's go in, and you can use any of Maya's animation tools. So this is just Maya, basically, I'm talking about here. I'm going to create an animation layer. It's the simplest way of offsetting animation is just to add a little offset with an animation layer. So I'm going to grab the hands, and I'm going to grab the hips. I'm going to create an animation layer for that. I'm not going to bother naming it. I'm going to come in here, and I'm going to offset that. So watch the vertical placement there. I'm going to make him stand up. I'm going to set a keyframe, and then I'm going to process that to the game. So this little button on the lower left, watch the game. Now he's got a completely different idle. Now his hips are much higher, so that when I actually hit the do jump button or hit the jump button, now it's going to transition at the right spot. So I can go in and I can make these changes back on the Maya side pretty much instantaneously and have that automatically update in the game. So that's it's pretty powerful. You no longer have to wait on a programmer to put that in the game and then tell you what it looks like a day later. So let's go back to mine. We'll talk about something a little more complex. So I created a very simple condition, but you can actually create some very, very elaborate conditions using utility nodes and math nodes and whatnot. So I'm going to bring back in the body state machine. And the body state machine right now is going to contain all the body animation for the locomotion. So what you'll see over here on the right-hand side is basically my node library. So you'll see I get a list of nodes. So I can create something as simple as an if-then node or something as simple as an add or subtract node. Or I could create something more complex and save it into this library like a state machine. So I'm going to bring the body state machine back. I'm going to take the body state machine and I'm going to put that into the output of, or rather input of my game, the output here. And what that's going to do is it's going to feed the body state machine back into my character. And now I have the original motion back. So one thing you'll notice here is that when I do my jump, I wish I could get rid of that barrel so I stop running into it. When I do my jump, notice how when he falls to the ground, he transitions back into the idle. So this is not just a simple transition, because what's actually happening here is depending on where he jumps from, it has to recalibrate how and when to do that transition. So if he jumps off the second story, he needs to be able to land at the right point. It can't happen in the middle. He can't start transitioning in the middle of his jump. So what I can do is I can create a very complex node structure that defines how and when that happens. So I'll show you an example here. If I go into the body state machine and I take a look at the fall to land, so basically I'm going from the jog here, which I can transition, or I can go from the jump. There it is. Actually, that's what I was doing. The jump to the fall to the land. The condition itself is not just a simple condition. If I dive into this, it's actually a very complex node structure, which contains even more complex node structures underneath. So it's kind of a hierarchical system here. So basically what I'm doing is I'm getting the velocity of the character based on the location, and then I'm doing a raycast from that to determine how far away he is from the ground, and then that basically determines how and when I do my blend, so that when he gets to the ground is when I'm going to transition into the idle. So obviously this is fairly complex, but I don't want to have to recreate this every single time. I want to be able to reuse this either on the same character or possibly even on different characters. So what I can do is I can take this node structure here, and I can composite this essentially into, composite's not really the right word, but I can basically put this into a container or a compound, and I can turn this into a reusable asset essentially. So I'm going to go into the naming here, and I'll just call this my time to land. So it's my time to land compound. And another thing I can do is I can actually expose parameters or expose values from within this so that artists can use it. So a technical artist would create this and then make it available to artists. So what it's actually doing is it's using a hard-coded value to determine the time from the landing that the blend should happen. So right now it's 0.15 seconds. So I'm going to take that value there, and I'm actually going to feed it into the input over here, and I'll just call it time just so I can recognize it. And now if I go up a level, you'll see now I have an input called time, which I can now drive through another connection. So I'm going to save this out. I'll just export this compound into my library. I'll just keep the same name. Now I can actually delete that, and I can just bring it back in at any point. So if I filter up here for time 2, now I've got a compound that I can just drag back in, and I can reuse that as many times as I need to. The other thing that I can do is I can make this compound available as a condition. So for instance, if I right-click on here, I can tag this compound and tell Skyline that this is a condition. I want to be able to use this on a transition between states. So I'm defining this. If I can actually type, it would help. Defining this as a condition. Now I can go back up to the body state machine, and I can just reuse this. So for instance, if I start from scratch, I'll delete the connection from fall to land. When I do that, it has to recompile, basically process into the game. Does it pretty quickly, though. So now when I go in and I go from my jump up to my fall and then to my land, or actually it doesn't even know how to get to land. So I have my fall. I'm stuck in that state. I can't reach the landing at this point. So now I want to create the connection to land, but when I do that, now what it's going to do is it's going to give me a generic transition. So now notice how he's transitioning at the very top. He's actually transitioning into his land right as he starts to fall to the ground. So this is where that kind of elaborate calculation comes in. I want to use that raycast that I created, that compound, to determine how far away he is from the ground. So let's see if I can actually find this. There it is. No, actually, did I not put it in here? Looks like I actually didn't define this. Let's try that again. All right, so try this one more time. There it is. I think I misspelled it. So time to land now is a condition. I can load that in. It automatically loads that complex node structure and exposes that one parameter that I defined that the artist needs to be able to tweak. So now the artist can come in here and say, I want him to start to transition at 0.1 second from when he reaches the ground. So now that's going to recompile. When I come back in here and run through this, now when I go in and I do my jump, he's going to jump, and then he's going to transition at just the right time, which is right when he's about to hit the ground, or right as he's hitting the ground, basically. Okay, so I have a few more things I want to talk about here. Let's talk about how we can actually composite state machines together. So in addition to blending at the lower level where we're blending individual clips together, we can take an entire state machine and we can blend that together. So right now I've got a body state machine. You'll notice I mentioned this earlier, but when I run around and I shoot, notice when I shoot, I'm actually firing my weapon, but his body is not reacting. So his body is not actually firing the weapon. So what I want to do is actually use another state machine that allows me to transition between different types of shooting. For instance, I have point of view shooting, and I have quick draw shooting. I can also go into an aim mode where I can aim from the kind of the third-person point of view. So what I want to do is bring in the state machine that I had before, which is called my weapon state machine. And again, these could be applied to different characters. So I could define this once for a male character, and then I can reapply it to a female character, which is why it's nice to be able to save these out. So now what I want to do is actually blend these together just using a simple blend. So a blend is actually a complex node structure, but as an artist, all I care is that it's a simple node that allows me to blend things together. If I dive into this, you can actually see that the blend itself is made up of a lot of other nodes, which in themselves are made up of a lot of other nodes. So it's very complex, but again, as an artist, I don't really care. Somebody made this for me, I'm just going to use it. So I'm going to come in here and expose the ports that I care about, which are the input ports for the animation. I'm going to take the body animation, and then I'm going to composite the weapon animation on top of that. If I can actually, I got the wrong clip there. I meant to bring in weapon state machine. So I actually brought in a compound by mistake. There we go. So now I've taken the weapon state machine and I've comped it using a layer blend on top of the body state machine. Now I'm going to feed that into the animation output here. And what you'll notice with the layer blend, just one thing to point out, is that just like in Maya, when you're dealing with animation layers, you can set different types of blending. So I can either blend using an override, which will basically overwrite the animation below it, or I can do something like an additive or a subtractive blend. So if I wanted to composite animation as an offset, essentially, I can do that as well. So if I go back to the game now, wow. I wish you guys would yell for me like that. I guess you're not going to, though. All right, so what you're going to see here is that as I begin to fire, now the upper body is going to override, the weapon is going to override the upper body animation. So one thing that I want to point out here is that if I come in and I actually do this from a different point of view, let's say I'm crouching and I go into crouch mode and then I fire forward or fire to the right, it's only going to affect the upper body, but if I fire to the left, it's actually going to override the entire body. So there's a problem. So this is a good example of how I can diagnose a problem and then go back and fix it. So what's happening is it's doing a composite or an override of the lower body when really that should be masked out. I should actually set that as essentially not overridable, for lack of a better word. So what I can do here is I can go back to my state machine. So I can come in here and I can start to trigger these, and I can go back to my state machine and I can look at the history of what I've done, or I can actually just dive into the node structure and take a look at the node structure. So for the weapon state machine, I've got an aim state for the point of view, and I've got a quick fire. So I know it's the quick fire that's the problem. I can dive into this and see what's going on and say, well, I've got a few different clips that are defining this. The one that's causing the problem is actually the left fire. So I've got a clip in here called ready fire mid left 90 degrees, which basically is the 90 degree left animation. So now I'll go back to Maya, and I'll just drag that animation in. So I'm going to find my weapon ready fire mid. I'm going to drag that in. Actually, sorry, double click that. That'll bring in the associated Maya file. So one thing I want to point out is that, again, this is a composite. This is actually affecting everything. So if I go into jog mode and then I try to fire my weapon, notice how he starts to slide. So it's actually affecting his, whoops, sorry, I got to get rid of that. It's actually affecting not only the crouch, but it's affecting the run too. So I've got all these problems that I need to actually correct. But it's really one problem. It's just affecting a lot of different things. So anyway, if you'll look in Maya now, actually I've got a little bit of lag. Let's hold off here. I guess I could show that one more time. You'll notice the feet actually move a little bit. So there we go. I'm going back into Maya. And if I play this animation, what you can see in the animation is that his knees are actually bending a little bit. So it actually has animation on the lower body. I just don't want to use it. So what I can do is I don't want to necessarily edit the original animation. I just want to control how it's composited. So the clip itself has information on it. So the clip editor over here on the right-hand side tells me the beginning frame and the end frame of my animation. I can actually technically have multiple clips from a single file. I only have one for now. But then it also has a bone mask pull down that allows me to filter my animation. Let me get my character back into a position where I can actually see this. So if I take a look at this from the crouch point of view, there we go. So you can see what's going on again with the feet. I just simply go to the bone mask and I say I want to mask out only the upper body. Now instantly it's going to go in and only affect the upper body. So now it's not doing that. If you want to see a simple example, if I just filter the left leg as well, now the left leg is going to be affected by that clip. So you notice how instant it is. If it's something more complex, like if I change the animation, I have to actually bake that down to the joints and process that. If it's something as simple as changing a mask, it's almost instantaneous. As soon as I change that mask in Maya, it immediately updates in the game. So the last thing I want to show, and I'm running over time, but Sean gave me a little leeway to go a little long. So I'm going to show one more thing, and that is the ability to do HIK correction. So I don't know how many of you are actually familiar with HIK. Human IK is another of our GameWare products. It's basically a real-time Human IK system based on what actually exists in Motion Builder, if you're familiar with that. We've actually integrated that into Skyline so that we can use it to do things like corrective animation or even potentially retargeting. So right now what I've got is if I come in here and I actually kind of walk my character around, what you'll notice is that as I begin to fire, if I go into my point of view, notice the FK animation is kicking in for the arms, but it's not actually reaching the target. You can actually see it here if I kind of point down at the ground. See where the target is and where his arm is? The FK animation's working, but it doesn't really work for where that target is. So what I want to do is actually figure out where that target is in the game, and then use HIK to point at that target. So I've got a simple, or I've got a whole series of HIK nodes in here, but I've got a compound that has been pre-created for me that does a correction. It's called HIK correction. Now, assuming this compound has the appropriate inputs and outputs, I can actually drag it onto an existing connection, and it will just splice right into the node graph and basically feed the output, or rather feed the output of layer blend 2 into it and then correct it and then send that to the game. So now what you'll notice is when this updates, notice where the target is. Now he's actually going to point directly at that target, regardless of what point of view I'm in or what mode I'm in. You can actually really see it here if I kind of aim. Whoop. Sorry, got to get in the right mode. If I kind of aim high, notice how his arm is actually correcting to point at that target. So at a lower level, for the kind of more technically minded people in the crowd, I'll kind of dive into this and show what's going on. Is it's actually going in and it's extracting data from the game. So we can actually pull data from the game and then use that within the node graph. So I'm using a node called get data here, which is actually figuring out where my target location is in the game as I'm playing. And then it's basically feeding that into a series of HIK nodes, which are then essentially correcting the existing FK animation. So that pretty much wraps it up. I appreciate your time. If anybody has any questions, feel free to come up and talk to me on the side. I'm also going to be presenting this again tomorrow night if you want to get a second look. Or not tomorrow night. Am I going to be here tomorrow night? I hope not. Tomorrow. All right, thanks, everybody.
Thanks a lot, Stephen.